to Maths Appeal. I'm Bobby Seagull.
And I'm Susan Okereke.
And the aim of our podcast is to show that maths is for everyone and to show it's kind of fun.
Yep, and if it's your first time in listening to Maths Appeal, welcome along. It's great to have you with us.
And an extra big thanks if you've listened before, or if you've taken the time to write a lovely review for us. We really appreciate it.
Yeah, we do. Thank you very much. Our main topic this week is statistics, and after Bobby and I have discussed it, Bobby will set a puzzle related to it.
And while you're working out the puzzle, we'll hear from our guest, and this week, it's the first part of an interview with Dr Anne-Marie Imafidon, the founder of Stemettes.
She is such a dude. I met her a little while ago to find out about her maths story, and she really is an inspiration. She loves maths. She actually did her maths GCSE when she was 10 years old. I know, bonkers. And then went to study in Oxford and is devoting her career to encouraging more girls to get into science, tech, engineering and maths.
And after that, we'll go back to our puzzle and show you our calculations, and we'll round things off with our regular maths fact. A little bit of trivia you can show off to your friends, family or people at work while you're waiting for that kettle to boil.
Right, so let's get on to talking about statistics. So, Bobby, do you have a definition of statistics?
Yes. Computer, what is the definition of statistics? Collecting and analysing numerical data for the purposes of making inferences.
Nice, okay, right. My definition for statistics is a branch of mathematics dealing with data collection, organising, analysis, interpretation, and presentation. Okay, and so this section is Bobby and myself, as maths teachers, talk about how we present this to our students, and we generally set it up in 3 different points. 1, we first think about what comes to mind when we are going to deliver the topic. We then think about how we introduce the topic to our students, and then we think about and talk about the common misconceptions that come up when we are teaching this topic. So,
should I begin?
Shall you? Yes, please.
Yeah. So actually, when I think of this topic, some teachers might not agree with me, but I always think of mean, median, mode straight away, the averages. Is that what you sort of think of, like when you think of stats as a school topic? Well,
that's the thing. Statistics for me is a topic that I know, reflecting on it, I don't teach very well, if I'm honest. It's so incredible because it has a massive impact on the world we live in. Data, we're in the age of information.
Yeah, we are.
Data is kind of that it runs the world. We kind of give it over all the time, but actually our understanding of it is a bit poor. And generally, when thinking about it, I realise that what I deliver, and I think maybe a lot of teachers deliver in the classroom, isn't actually what the real world statistics is.
Yeah.
So it's breaking that down. But as you say, the whole averages is a start, but it's the whole collection part that I quite kind of enjoy doing, but it's always small scale, you know?
Yeah, it's the collection part, whether you're a geographer and you're going out on a field survey to Wales and measure the speeds of winds or rivers, or if you are a English student and you're collecting data about a potential book you're writing and the size of the audience. So I think even sort of people that are non-mathematicians, you are collecting data, but they don't see it as mathematics or statistics necessarily. They just see it as, I'm doing something for my job, or I'm doing something that's required for my geography project or English project.
I think also as well, a lot of people don't really understand the process of data collection. So as not just data collection, but the uses of data. So things like the collection that are it's a sample that's used, who's actually been doing the collection. Also, when it's done, how is it organised? Once it's organised, then what do you do with it? You analyse it, we organise it, then you analyse it, and then you can make inferences from it. But I think that's what we try and kind of put across when we're teaching. But a lot of the time, I don't know the examples that you use, when you want to get the kids to collect, one of the activities I think a lot of teachers do, I might be wrong. If you have any suggestions, please share it at Maths Appeal. But it's that whole idea of students, measuring height, measuring handspan.
Yes.
What's your shoe size? What's your date of birth? All this type of stuff. And which is great. I think it's really good for them to do that. But data is massive. So now I realise there are loads and loads of online websites that have loads of big data sets that you can use that can be really great for getting kids to understand how important it is and how it's used day to day.
Yeah, because I guess the classic one of asking kids, what's your height? And then let's work out, the mean, the median, mode for the different ranges. It can sometimes feel a bit artificial.
Yeah. Also, yeah.
Yeah, I just think like if you're a child, you think, oh, this is only statistics, what's happening in my classroom. I want to see actually how it sort of impacts the real world.
But I think it's also an issue a lot of the time that students don't necessarily understand what the whole concept of average is. And that's something that I think is really important because it's a number that represents a big set of data. So one number that represents a big set of data, and there are three different averages that we talk about in maths. There's a mode, which is the most common thing that comes up.
Yeah.
There's the median, which is our middle value. And then there's the mean, or what most people know of as the average, which you add up all the number data and you divide it by however many numbers there are.
And that's the arithmetic mean.
Yes. Yeah. And that's the one that, say, scientists use generally, I think, as well, and like geographers, and that's kind of what most people, I think, kind of like look at. But it's the understanding of what that means as it's one number that represents loads of numbers, which is kind of bonkers to get your head around.
Yeah, because I think sometimes as a teacher, even I'm guilty of getting students to go through the process. Imagine we've got three numbers, 1, 3, and 5, and we're trying to work out the arithmetic mean of it. You know, we do 1 plus 3 plus 5 is 9, divided by how many does 3? 9 divided by 3 is 3. But you forget what that 3 means. You say, I've got 3, that's the answer.
Yeah.
So it can become quite driven by the method.
Procedural as opposed to like what's the understanding of it. Because actually all that would make that better is for you to go, that 1 represents 1 sibling, that 3 represents 3 siblings, that 5 represents 5 siblings. So the average number of siblings is 3. And so when there's a decent context to it, it kind of helps with the understanding. But a lot of the time people just see numbers as numbers, and actually what they all represent with any type of data collection, it represents something, whether it be how often trains are late or how many...
Never.
all the time, or how big a population is or something like that. So it's kind of, I think context to the numbers is really important.
Yeah. And again, with statistics, I guess with this topic, it really is a subject of mathematics that is applied and seen in everyday life. You know, things like, we love algebra, but, you know, kids can say, oh, sir, miss, I don't see it in the real world. Whereas statistics, they'll see it in newspapers. You know, when you're looking at Brexit, the vote, or Britain's Got Talent, or you're looking at the economy, or you're looking at sports results, stats is everywhere.
Yeah.
So if we can give young people and adults the sort of tools to actually interrogate, is the data, so the presentation of the data that I'm being given, is that a fair depiction of what's really happening, or is someone trying to hoodwink me by using stats in a sort of deceiving way?
That's the big issue, isn't it? You can't be, what really should be happening in schools and beyond is encouraging people to be critical about what they see. You know, and as you say, data can easily be manipulated, and it's the way it's represented can create bias, and that's what everyone should be made aware of. And that's kind of looking through a variety of things. There's a website called Gapminder. Have you heard about them?
No, I haven't.
It's incredible. So
what's it called? Gapminder?
Gapminder, yeah, and it's kind of a collection of loads of international databases, and so. Guy called Hans Rosling, his son Ola Rosling,
of course, now I know it.
And Ola's wife Anna Roland, I think. They put together this incredible website which has infographics of data from around the world, so you can do a comparison. You can literally see bubble infograms where you can sort of see how different populations fare over time. So the reason he kind of put this website together was because he did lectures. I think he was a lecturer in a Scandinavian university, and he realised that a lot of people had really skewed ideas of what was going on in the world. So you ask people like, is poverty better now than in the past?
And people think, oh, it's worse, the world is worse.
And he was like, he wanted to find out whether it was true, did the research and realised that actually poverty is much better now than it ever has been, and things like mortality rates around the world have gone down, that child mortality rates have gone down. And he was like, and he was doing this lecturing sort of postgraduates who were making these assumptions that were fundamentally wrong. And so they put together this website because they wanted to unveil the beauty of statistics, but in a world, like making people aware of what the reality was.
Yeah.
And I think it's so powerful. So I've only recently found out about this website, and this is a website that I really want to start using more in my classes. I think it's also one that everyone should look at because, if the experts are ignorant, we are really, really ignorant. Yeah. And actually no one should be about kind of world things because actually they define our choices. And that's what the power of statistics is. It kind of helps you see trends around the world, which, you know...
You can see it quite quickly, because obviously if you read, a few paragraphs on something, it tells you here's what's happening. But actually, a chart or a table or an infographic can actually quickly cut through all the noise, and you can see actually world mortality rates are dropping, life expectancy is increasing. So it can be quite a cutting through the arguments very quickly sort of tool.
What they say, isn't it? What a picture speaks 1,000 words.
Yeah.
Indeed. But the other thing, though, with that is trying to encourage people to think beyond it, because those pictures can also be manipulated. That's our thoughts on statistics. We would love to hear how you deliver statistics if you're a teacher. Also, if you are not a teacher and you work with it, how do you use statistics? It'd be great to hear from you at Maths Appeal on Twitter and on Instagram. Our next phase, it's time for puzzle time. Bobby.
So you ready for some sequins and glitter?
Oh, yeah, always ready for sequins and glitter.
Are your dancing shoes polished?
Always polished, Bobby.
Well,
He really was moving his hips. It was quite special.
I was, wasn't I? Well, I'm a huge Strictly Come Dancing fan. So we have a Strictly themed puzzle this week. Got your pen ready?
Yes, always.
The judges, Craig, Darcy, Shirley and Bruno, each give a score between 1 to 10 for a dance couple. One couple does an unusual performance with mathematical patterns, and so attracts a wide disagreement in judging scores. Shirley and Darcy both give a score that is double that of Craig's. Assume the average score for this dancer is 6, and Bruno gives a score of 9. What scores were awarded by Shirley, Darcy and Craig?
All right, one more time. One more time. I also want a clarification of what average you're looking for, please, Bobby.
Ooh, can I... No, okay. Average, you mean arithmetic mean.
Thank you, right.
Thank you, very good clarification. So we've got the judges all giving a score between 1 to 10. And in our particular question, Shirley and Darcy give a score that's double of Craig's.
Usual, isn't it?
Yeah,
he's very tight with his scoring.
Exactly. So this question reflects reality. And the average score for this dancer is 6, the arithmetic mean. And Bruno gives a score of 9. So you have to work out what Shirley, Darcy and Craig gave.
Right, I've got that down. Got my ideas. Thank you very much. And while you're working that out, let's hear from our guest, Dr Anne-Marie Imafidon MBE.
I can't wait to hear this. Really sounds amazing.
Oh, I had such a great chat with her. We decided to split the interview into 2 parts. She is so great at talking. It's brilliant. In the first part, we find out about her maths story, passing 2 GCSEs at the age of 10, going to Oxford to study maths and computer science, and why she loves the subject. So here we go.
I'm Anne-Marie Imafidon. I am CEO and founder at Stemettes, which is a social enterprise that works with girls and young women to inspire, support, encourage them into STEM-related things, STEM being science, technology, engineering and maths. Yay! Yes.
And how did this come about? So because your story is quite interesting.
I grew up in East London, near Stratford, and I have always liked to understand how things work. It's always been my thing. And that meant taking things apart in the house when we were younger that we really shouldn't take apart. So don't know how many people listening, maybe the older people listening remember VCRs, like a thing, like loads of tapes and loads of springs and loads of things inside.
You took it apart?
That's one part. I just took things apart to try and understand, because it was like, how does that work? Like, you put any tape in and it just continuously plays. So for me, I've always been a very logical person because I've always wanted to know how things work. And maths is incredibly logical. And 2 + 2 is 4, and was when the first person realised that, and that person's dead and long gone, and there are people being born today for whom 2 + 2 will always be 4. And there's something nice about that logically working and being applicable continually, which there's not really anything else in life that's kind of that beautiful.
Definite.
Yeah, and it's a thing that people always like, oh, I like maths because there's always a right answer, which for me it's like, there's a right answer, but it's not even in the answer, it's in how you get to the answer, that there's a right answer, that loads of people might use the same method, loads of people might use a slightly different method, but the logic got you to the same answer, which human beings are not like that at all.
No.
At all.
A lot of variation in us, right?
There's too much variation. If you ask me. Everyone's always like, what's the hardest thing about what you do? And I'm like, I have to work with human beings. And if you say hello to them today, you say good morning, the response you get with the same hello and the same good morning tomorrow is very different. But it's got nothing to do with you.
But the mathematics just constant.
It is so stable, so solid. Maths is and it's not even like science, where again,
there's variation.
Someone will be like, oh, well, we didn't realise asbestos caused cancer, and now we realise. So for me, from when I was really young, I really enjoyed that and loved learning more about it and just applying it, and the fact that it just worked.
Mm-hmm.
So did 2 GCSEs when I was 10.
10. So wait, and I'd really like to know how you got to that, because that's quite... Not bold's not the right word, because your parents would have sorted that. But how did they know to put you in for GCSE?
I was young enough that there's only elements of the story that I guess I truly know. The thing was, in maths, in primary, or numeracy as it's called in primary, a lot of it repeats.
Yeah, very much.
And my thing is, if you've told me once and that worked logically the first time, I remember the logic of what it was, so you don't need to tell me again. And again and again, and every year it repeats up until I think year 8 or something. So
and it repeats at secondary school, my friend.
Right? Yeah, no, up until year 8. So up until like key stage 3.
Yeah,
it's still the same. It's kind of shades of the same thing.
But
right?
the GCSE foundation fundamentally is the primary school curriculum.
Yeah. So for me, it was like, you've already said this, and I already knew it. And so I'm going to go and just bounce off the walls. So you
needed to stretch.
So the teachers are a bit like,
get her done.
Guys,
yeah.
Something Just winding us up, please just give her something else to do. Maybe try this, like I've heard that people sometimes do this. And so my parents were like, oh, okay. No, your parents were like, yeah, she can be the best at this one, I'm like, go for it. And I was a bit like, oh my god, more maths, yeah, you have to repeat the same thing to me again. So that's how I did it. And IT was alongside this, because again, it's still quite logical in the main. And so those two things kind of went along side by side.
So you did your kind of pure stuff with your applied, which was this computer?
In effect, yeah. But without really realising at that age that they were connected.
Sure.
Because they are, but not realising it. And actually the syllabus and the curriculum don't connect them as much as they could do or should do, or whatever. So did that at 10, the 2 GCSEs, and passed them, which I was as surprised as anyone else would have been. It's like in print now, I famously say, like my dad took me to McDonald's, that was like a treat. And I'm the eldest of 5 as well, I didn't have to do any washing up for a week, which was just amazing. It was like, you know,
living your best life.
Literally. 10-year-old Anne-Marie was like, this is it. So there's a bit of me, there was like a lot of me that was like, hey, I was surprised that it worked, because you never really know this is a thing that's going to be for real. But I was like, I'm going to give it as best as I can, and I actually quite enjoy it. I will say, for purposes of the podcast and those listening, circle theorems.
Oh, yo.
Not my thing.
But you know what? Teaching them, they're so big and they're so interesting, but a lot of the time they're not done in a way that kind of brings to life. There's loads of dynamic ICT apps and things that now will make a lot of sense, but to teach them...
In the olden days when I was doing this...
Just a bit of paper.
It was just like... And it was, I think it's 15 of them, or 14, something like that. Yeah. And I'm just like... Even at that point, I was like, I don't...
Even at 10.
Even at 10, as I was prepping, percentages were fine, decimals were fine, algebra was fine, everything else. But circle theorems, it's like there wasn't any logic behind them. It was just memorise these theorems and apply them.
I'll show you something one day.
You will? I'm sure I'm going to go and do it now over Christmas. But it's one of those things where, so like, not everybody gets everything, but I got enough of it that was logical enough.
To take you to university.
To Oxford, a year early, to go and do maths and computer science together. Wow. Which again, brought it even closer together. But I really enjoyed it. I really enjoyed it. I think it's one of those things where, and I'm sure anyone else will say it on the podcast, but when you go from school to university, for maths, there's a jump anyway from GCSE to A-level, and then there's a jump again from A-level to university, but all it is you having to do a bit more work to be able to peek behind and see why differentiation, for example, which comes up in the A-level syllabus, works. And again, it's one of those things that differentiation always works. It's not like a computer, like sometimes you have to switch it off and reboot it. It just works, and it's L'Hopital, it's all these other people who did all these things that worked them out hundreds of years ago, and you're like, okay, cool. When I then piece everything together and bring that theorem and that one that was derived from that, and then I put them all together into a proof, which is what you spend a lot of your time at university doing in maths, you're like, oh my gosh, like look at the beauty, this is like behind the scenes of what it is, and that person like that. Well, they just did a tiny little bit, and they just did a tiny little bit, and then today we can differentiate, because all those 50 people spent years of their lives doing slightly
different things,
vaguely correlated things that all come together today.
Oh gosh, you love maths, right?
I really do. and honestly, and it was so funny, so even like third year, so then you've done all that, you've peeked behind, and then third year we did, I think it was Galois theory, and got Galois theory, and some people will get it up as one like again, you're missing out. Galois theory brought together like everything we'd ever done in algebra with everything we'd ever done in groups.
Oh yeah, group theory, yeah.
And it was like everything just beautifully, and it was almost like, I don't know, what's the thing where you like kind of click something together? You know, like you find stuff that's spheres. So this is like, because obviously I like to know how things work. You know, sometimes you'll see something, you'll be like, how does that click together? How does that fit together?
Yeah.
You know, spheres, it's always a thing. So even when you bake, trying to get the sphere together, like to get it together and fully spherical, you have to like treat the bits separate and then bring the two hemispheres together. So that was like, I remember like third year university, where it's like two like incredible ideas that I really enjoyed, then just came together and kind of clicked, and you're like, oh my goodness.
You love them even more.
Yeah, I love the beauty of it. The only frustration was I'd spent 3 years, probably my whole life studying this. Just trying to explain that to anyone. Still now, I struggle to find people that can be like, yeah, Galois theory. In the same way that I'm like, yeah, Beyonce. Like for me, like or Beyonce, right? So for me, it's like that kind of thing of this. It just all comes together.
It's the connections. I think that's something that actually I think schools aren't always like good at highlighting for people, that actually loads of the subject do connect. And actually, if we spend more time playing around and people discovering these things, it can be wonderful. That, as for me as a teacher, like I quite liked a lot of things, but as I've learned more about them, I'm like, it's amazing.
And I think that's the biggest thing that gets lost in school, is that math in particular connects to real things and real people. Yeah. The easiest thing is, you know, you pay taxes, you pay for chocolate bars. Like the easiest thing is
money,
money.
Yeah. But not
everyone's driven by money. And so when you then pin it to, you know, you can use probability to treat people better with certain conditions, because you're able to take all the numbers from their trial so far, work out what that probability is, and then decide that actually you're going to give that type of person that operation or that type of person that treatment course. Yeah. People do care about that. And so you're like, if that's the reason why I need to learn about fractions, percentages, or about statistics, then why wouldn't I do it? Because I know I'm going to use it, and actually, it's not even that you know you're going to use it, you want to be able to use it so those people feel better. Right. But no one ever makes that connection. They just say maths is really important, and they tend to be a maths teacher. Yeah. And so you're like, okay, it's only ever my maths teacher that said maths is important. So like that. And then you're like, something fishy going on here. My maths teacher wants me to join them in their misery as a maths teacher. Do you know what I mean? That's what a lot of people's experience is.
If it's not sold well, and that's the thing. I think on some level, as teachers, we are cheerleaders, promoters, marketers of our subject, and actually, wholeheartedly, I believe that maths is important. But even as somebody who does, my knowledge of the bigger picture is quite limited, and that's why what you're doing, I think, is so wonderful. Can I just quickly ask you? It sounds like you really loved your university time at Oxford. In a genuine kind of sense, you didn't find any issues regarding it. It was just that you were in.
So it's funny. So it's something. I think so you live life, right? And then I'm the kind of person that doesn't really look back and like necessarily pull together. I mean, I am a mathematician, but I don't necessarily pull together the patterns of like, that's interesting.
Oh, right, yeah.
And so I didn't notice I was one of very few girls on my course, because in my college I wasn't. It was mostly girls. Even in lectures, you don't really notice because it's just you and your group of friends. And computer science was the same. So in computer science, there were 3 girls and there were 70 people in the course. Whoa. But again, you never noticed because you were just chilling, like genuinely.
And you were doing your work, and you didn't feel it was never made an issue.
Yeah, cool. No one was ever like, oh, your girl will sit next to you, or any of that kind of stuff. Looking back, there might have been boys in the course who were scared of girls, but they weren't the ones I was talking to because they were scared of me, so I never really noticed. Do you know what I mean? Like, it's one of those things, so you never really notice. So I really genuinely enjoyed it, and the other reason why I really enjoyed it, which I think is a maths thing, but specifically for Oxford for maths, was when you do your cheat sheets or your problem sheets or whatever it is, when you feed back on those, you do that in a very small group.
Oh, right.
So you're not in a lecture all trying to pitch in or whatever it is. It's a very much like you and the professor and maybe maximum 2 other people are there in that conversation.
So it's quite safe.
Yeah, so, and it becomes very safe, especially if you have a good professor, which I was really lucky to have. Which is that you then, again, don't feel like the only girl or the only whatever, because that dude is also the only one with curly hair. And that dude is the only one from Korea.
You've all got USPs.
Do you know what I mean? So everyone is the only, so there's not really an odd one out. I mean, collaboratively together, you probably are seen as the odd one out because you're the one that did maths. So like, against the wider population, everyone is a bit like that. But then within your group, you don't feel like other.
Yeah.
So I really enjoyed it and never noticed.
Cool, okay.
That I was the only black person in my college across all of that comp and maths, And that's probably the first time in my life I've said that.
Wow.
I've only just realised. And then in my course, gosh no, let me dig deep. Yeah, in my course. So there's all these things where it's like you're the only, but if you're not made to feel like other,
It's cool.
it doesn't matter. And it doesn't hold you back. Like you do exams.
That's all that matters, really.
Right, so it's not promotion, it's not, trying to get a job.
No, you've got to show yourself.
You've
got to prove.
University. Yeah, so it's you and again, it's you and the numbers, or you and the logic. And so either you get it or it's circle theorems and you don't. And then and that was it, right? So there was no like made to feel like this or made to feel like that. The numbers can't make you make you feel like this or the other. So I genuinely really enjoyed it.
So that was Anne-Marie Imafidon, and we'll hear more from her about Stemettes on next week's podcast.
Yeah, it was great. It was so much fun speaking to her.
I love that interview. I was, laughing, lolling along. Brilliant.
Yeah, it's funny because she is so passionate. But also, it sounds really bad, but when you hear somebody's got their maths and computer science GCSE at 10, you kind of want them not to be so nice. And she was a lot of fun. Like she was and a massive cheerleader for mathematics. And like, I thought I was a cheerleader, and I'm like, wait a minute, she can teach me a lot of stuff.
Yeah, she's from Newham, East London, represent.
Posse. So, and I learned a lot from her as well regarding kind of the application of mathematics, which I just think a lot more math teachers need to have, actually.
Well, the maths teachers, we can explain what circle theorems are, can't we?
Oh, well, yes. I mean, it's funny how passionate she was about maths, but not circle theorems.
So how would you explain it to someone?
Okay, well, it's one of those things you teach for higher GCSE where you've got circles and lines intersecting in them, and then there's loads of relationships between angles that are subtended by like the chord and stuff, and they're they can be quite beautiful, but it's a lot of information that you quickly go through and you don't get a chance to really, really explore, and that's a real shame about it. So it's one of those things that you'll probably learn it if you don't take maths any further. You don't really.
Again.
Yeah, exactly. What I'm really looking forward to is next week's part 2 interview, because then it tells us about the incredible organisation Stemettes that she has co-founded, and it's doing amazing things with young girls between the ages of 5 and 22, and opening their eyes to the world of science, technology, and mathematics.
Can they extend it to men at the age of 34?
Hey, I think they're kind of open to people popping along. So, I think we should definitely go visit.
Yeah.
So I think now it's time for puzzles. Let's get back on it, Bobby. Can you remind us of what the puzzle was?
Hold on, I'm just going to get my dancing shoes on. Oh, I like that.
You're welcome.
So here's the puzzle. So the judges, Craig, Darcy, Shirley and Bruno, each give a score between 1 to 10 for a dance couple. Shirley and Darcy give a score that's double of Craig's. And we assume that the average score for this dancer is 6, and Bruno gives a score of 9. Mm-hmm. So what were the scores awarded by Shirley, Darcy and Craig?
Okay, should I talk you through what I did?
Yeah.
I'll show you my working out here, Bobby.
I love the working. And I love it when you post it on Instagram and Twitter.
Yeah, well, it's there. I mean, we really, really want to see how other people do it too. So we'll share it at Maths Appeal. You'll be seeing this very soon. I'll talk you through what I did. So we're looking at the arithmetic mean, right?
Correct.
So, and it says the average score is 6, right?
That is correct.
And there are 4 scores in total.
Yes, you're on that. You're on the
so
money.
the total scores, when you add them all together, is actually 6 times 4, right? And so that's 24. So if you were to add up all the scores, they would be 24. Shirley and Darcy and Craig's scores all together then are 24 take away 9, which is 15. Mm-hmm. Then I did a bar model because I love those, right? And so what I realised was Craig is 1 part and Darcy is 2 parts of what Craig is, and the same for Shirley.
That's right, yeah.
So in total, there are 5 equal parts, okay? And those 5 equal parts equal 15.
Exactly, that's right.
And so then to get 1 part, which would be Craig's score, I did 15 divided by 5, which is 3. And then the other 2 parts then are 6 and 6. So Craig's score is 3, Shirley's score is 6, Darcy's score is 6, and Bruno's score is 9, which we were told anyway. Ta-da!
Exactly, good. Yeah, perfect working out. Some people might use algebra instead. They might use letters, X, but the bar method works essentially the equivalent of it anyway.
Yeah, well, I mean, obviously, if you have any thoughts on this, and if you did it slightly differently or you came a different way, please share. I've actually got a point that I forgot to say. So do you remember the puzzle that you did about hamsters?
Oh, yes.
Right, so my friend, a girl called Connie, she did the working out and showed it to me, and you know what she said? She said that we totally forgot that Victoria and Albert would continue breeding. So, you know, we did it for the weeks. So we should have encouraged, we should have also potentially included Victoria and Albert continuing to breed their hamsters. And that was something I didn't think about. So again, please pick us up if we miss stuff off. So yeah, just spreading the puzzle love, hey?
Exactly.
Right, so that's puzzle done. And before we go, how about some maths trivia? Bobby, is there something from your book, The Life-Changing Magic of Numbers?
Oh, yes, there's something on statistics. So we've heard of Florence Nightingale?
Yes.
Yeah, the lady, founder of modern nursing. She sort of rose to prominence in the 1850s through the Crimean War. It was a tough war, lots of soldiers died in battle, but also from things like frostbite, cholera, dysentery, typhus, so not very pleasant. But what she did was she used statistics to present the causes of death. And rather than lists and tables, which are sort of common at the time, she actually presented the causes of death in a revolutionary way at the time. So a bit like a pie chart, but she's had something called a rose or a polar area chart. Oh, wow. It's almost like for every month. So in 1854, let's imagine, for January, you got death in battle, death by dysentery, death by typhus. And then the sort of each section of the pie chart went out. You know that pie chart's normally just a circle.
Round, yeah, circle.
Yeah, there's some bits of the circle that are larger.
Oh, right.
Actually go out into the 2D sphere.
Right, so it's kind of like an infographic.
Yeah, it's an infographic.
Was it proportional? So it was kind of, did it...
So, yeah, so if there was like a really large number of deaths because of dysentery, it
was
went
much
out
bigger.
Massively. So she was like almost like the pioneer of infographics.
Oh, wow. Who knew? Florence Nightingale.
There you go, stats.
Right, so thank you for that, Bobby. Always a pleasure. And if you want to send us some maths facts, we'd love to hear from you. So get in touch. We're at Maths Appeal on Twitter and on Instagram.
And next week, we're tackling lines and angles, and we'll hear about Stemettes from its founder, Dr Anne-Marie Imafidon.
So thanks again for your support, whether that's telling your friends or giving us a nice rating and review. Honestly, the support has been fantastic. And please keep telling your friends on Twitter and Instagram. It really helps the maths love, because we're on a mission to help Britain love mathematics.
Exactly that mission. So you've been listening to Maths Appeal with me, Bobby Seagull, and Susan Okereke.
And the music was composed by Kelly Okereke, the image design is by Calix Davis, and our producer is the wonderful, wonderful Jennifer Nelson.